right, yesterday, guys, on this homework assignment, I said that you could skip numbers 1, 2, and 3, and just go straight to the multiple choice, which started at number 4. So I think number 4 is actually one of the trickier ones. Number 4. Okay, number 4 is one of the ones that I think there's a technique to it that you might not be used to. And it's kind of a weird one to make sure that you kind of follow and get what's going on there. So here we go. Let me demonstrate. Alright, so box plots are drawn to, histograms have to be drawn to scale. Histograms cannot violate the area principle. So what that means is, if this box, if this histogram, if this bar right here is looks like half of this bar, then it contains half as much as the one next to it. Okay? So histograms have to be drawn to scale. And so because of that fact, we can approximate how many items there are in this set of data. So I'm just going to go with, say, this is, one item, one item, one item. Then how many does this bar next to it have? 2. How many would this one have?
3.
Okay, 3.
I got 7.
Now this one,
7.
okay, 1, 2, 3, 4. Okay, yeah. So there we got 7. All right. So if that's what you got, then how many items do we have in the entire set? If you counted, there are 15 items in this set of data. So if there are 15 items, then I can go ahead and I can find where the median is. Now, before we even start, one of those multiple choices should be able to be marked off. Which one should be able to be marked off? Okay, clearly the data is not focused up here. You do not have 75% of your data from 40 to 60. So that is a definite first one you would knock off. The other ones, you're going to wonder if your median is at 20 versus being at between 10 and 20 or 10. So if I have 15 items, then which numbered item is the median? So what number in the sequence?
8.
The 8th item. If you have 15 items, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, then the 8th one is the one that's the median. So if I count that, this was 7, and then here is the 8th one, so that's the median. Therefore, the median is located from 10 up to 20, but is not 20. So because of that, I can knock off 2 more answer choices. Which ones would I knock off? B and C, because the median is not at 20. Okay, now let's look at the 2 remaining choices. D and E have the identical Q1. What's the one difference between them? The location of Q3. So, if you have 15 items and the 8th one is the median, then which one is the Q3? Okay, wait. No, this one. It's this one right here.
Wait, you're not including
So,
the median?
no, you can, but you don't have to.
Wait, but if you include the median, then you get
I guess, technically, yes, but it would probably still end you up in the same location. Might be a little off. But anyway, so here we go. It's the 4th one from the end. So here is Q3. So Q3 is located between from 20 up to 30. From 20 up to 30. So that is here. It is not all the way up at 50. Okay, because if it was up all the way at 50, then how many items would be in the upper quartile? Only 1 item. Okay, and there's more than 1 item in the upper quartile. So therefore, what's our answer? D.
skewed right, that doesn't help at all, does
The fact that it's skewed right did automatically knock off A, but to me, B, C, D, and E are all skewed right. So then that doesn't help any further on those. Okay, so I do think that this one is a trickier one, but now that I've hopefully given you that knowledge that histograms are drawn to scale, then you can kind of go through and identify the items and what those things are. Okay, number 5 is one you definitely should have been able to get. A stem plot. It's the stem and leaf plots. Are they used for both quantitative and categorical data? What's wrong with that statement? Good. They are not used for categorical. They are things that are in order. So statement 1 is not true. Okay, number 2, stem plots are equally useful for small and very large data sets. Is that true? It's not true because a stem plot would be very, very difficult to do what? With what? Yes. With large data sets, if you have 100 items, do you seriously want to sit there and put them in order and do them with a stem and leaf plot? No. So, 2 is out. Number 3. Can a stem plot show symmetry, gaps, clusters, and outliers? It can. Do you have the ability, let me ask you this, do you have the ability to compute outliers with a stem plot? You do. Why are you able to do that with a stem plot? Good. You have the individual pieces of data. Remember, your stem plot is giving you the stem, and then you have individual pieces of data. Okay? And so because you have individual pieces of data, then you can compute the IQR and the outliers and all that. Okay, so then 3 is correct. C is 3 only. Very good. Next, number 6. If 10 executive salaries have 80,000, 6 have 75,000, and 3 have 70, 6 have 75, 3 have 7. There's 19 salaries there. There's 19 salaries. Which one is the median salary? The 10th one. Okay? There's 19 items. Okay? You're going to knock off the top and the bottom. Basically, you need to cut it in half. So what's the closest half to that? 9 plus 9. 9 plus 9. So 9 on that side, 9 on this side, leaves the 10th item as the actual median. Okay? But now hold on. You want to do this in order from least to greatest. So the first 3 items are 70,000. And then I have what? And I have 6 of these. So then that makes 9 items. So therefore, what is the 10th one? 80. Okay, so 80,000 then is your median. All right, next. Okay, with this number 7, this is actually a very, very important one for you to be able to understand and get. If you understand what standard deviation actually is, then you would get this. So let's say what the definition of standard deviation is. What is the definition of standard deviation? Correct. Average distance away from the mean. Okay, very good. Alright, so let's keep that in mind as we go through here. Plus, you know that the average is kind of the balancing point of these items. So, where would the average be located on A, since it's symmetric, and B is also symmetric? So set B is also symmetric. Where's the average going to be? In the middle, in the balancing point, they would average out to 30. How about this set B? The average is also going to balance out to 30 because they're symmetric. The mean and the median are the same, so they do have the same mean. How about the same range? That's the high minus the low. They are 50 minus 10, so they do have the same range. Okay? Alright, how about this? Both sets have the same variance. What is variance? Good. Variance, if you remember, okay, so variance is how much variation there is. And it's the standard, you remember the relationship between standard deviation and variance? It's the standard deviation squared. So if you take your standard deviation and you square it, that's what the variance is. Okay, so talk to me about this. Most of the items in set A are 15 to 20 units away from the mean. 15 to 20 units. Okay, do you see that? Most of these items are 15 to 20 away from the mean. How about set B? Most of the data in set B is how much? 5 to 10 away from the mean. If you have most of your data 15 to 20 away, how will that compare to most of the data being 5 to 10 away? Which one has a larger standard deviation? Or do they have the same? Do they have the same standard deviation? They do not. Which one's larger? The left one. Because more of the data is farther away. So the average away from the mean is bigger. This one has a larger standard deviation. So both sets do not have the same variation. So which one of those are true? Just 1 and 2. That's very important. That's a very important concept. You have to understand this idea of being farther away, more far away is a bigger standard deviation. Okay, question number 8. Given that the median is 270, okay, and then I'm going to draw the box here, and the IQR of the box, this is also another question that kind of messes with people's brain, but I want to hopefully show you a concrete representation that will fit. Okay, so let's see if we can't fix your, get you to understand this. Okay, so here we go. Question number 1. 50% of the data is at or above 270. That's what? That is true. That is the definition of median. Where is the median located? At the 50th percentile. So 50%, so median is at the 50th percentile, so 50% is above the median, which is 270. Okay. Now here's my IQR of 20. Does that mean that 50% of the data is between 260 and 280? Okay. The answer is not necessarily. Okay, watch this. Here's a picture of it being from 260 to 280. And then that would be true. But the box isn't defined as being located there. The box is just defined as being 20 wide. So could it, by definition, be located there from 255 to 275? Yes. Okay, Q3 ever be the same as your median? Yeah. So, in fact, you could have a situation where you have the median at 270 and your Q3 is also at 270 and it could go down to 250. Okay? So you could, if you just had like a whole bunch of items that were all 270, and you had like 20 items that were all 270, then guess what? Your median and your entire second quartile or third quartile could be the number 270. So it could even look like this, which would then put your Q1 at 250. Okay? So you have to get that just because the median, here's the thing, median is not necessarily right in the center of the box. I know it's 20 wide, it could be 20 wide anywhere. Okay, so let's go through these. Does that mean 50% is definitely between the 260 and the 280 mark? No, it could be somewhere else. How about this? 75% of the data is less than or equal to 280. It could be true, but it is not necessarily because I said this could be right there. Okay? All right. So that's also false. Therefore, the only one that is true is 1. Okay, next. Number 9. Given these parallel box plots, which of the following are true? Are the ranges the same? Yeah, they both have ranges of 6. So that's good. How about the IQRs? Both of the IQRs are 2, so that's all good. How about this? Both sets are skewed to both the lower and the higher values. I don't even know what that means, because a skew is bent towards one direction. Symmetric is like going, is both in both directions. So that's just total bogus, you don't have a clue what you're talking about statement. So the answer is D. 1 and 2 are true. Number 10. Now, this is one that I would have missed that I did miss when I first did this assignment because I forgot, and actually I really didn't know, so this is a way of teaching you, that histograms do not violate the area principle. If it looks like half, then it is half. Okay, so the size of the bar, the histogram bar, has to be related to how much frequency there is. So, if we look at these, this is 2004, 2006, and is it true that the revenue dropped in half from 2004 to 2005, and then in half again to 2006? Is that true? The bar looks that way, but that's not what's going on, because it just how much did it actually drop from 2004 to 2005? It only dropped 10,000 from 110,000. So it did not drop in half to 55,000. And this went from 10,000 to 95,000, or 100,000 to 95,000. So it did not drop in half. So this is not true. How about this? The choice of labeling makes for a misleading picture. True. This is incorrect labeling. All right. How about this? Now that I've told you the key to histograms is this statement true. The above picture is not a histogram.
It is because the bars touching you.
The bars are touching, that is correct. But what's another requirement of a histogram? They cannot violate the area principle. What is going on here? It is violating the area principle. Therefore, it is not a histogram. These bars are violating the area principle. Therefore, it is not a histogram. So, 2 and 3 are true. The answer is D. It's violating the area principle, so it is not a histogram. So that's true. All right. Okay, next, number 11. Here we go. this one talks about standard deviation being 0. Okay, so by definition, if the standard deviation is 0, then what are you saying? That the average distance, what? From the mean is 0. How can the average distance from the mean be 0?
That all observations are the same value.
Everything is the mean. Now, does that mean that the mean have to be 0? No. If all you guys are 5'8", then we would have a standard deviation of 0. The mean, if all you guys are 5'8", what's the mean? 5'8". But if all you guys are 5'8", then the standard deviation is 0 because y'all are all the same value as the mean. So that is C. Okay. Okay, here's another one, number 12. This is that box plot thing. First of all, you should knock off 2 of these because based on the box plot, what is the shape of the distribution? What's the shape of the distribution? Skewed left. So C is not skewed left. D is not skewed left. Can you tell me what the heck's going on with A? Yeah, what the heck? We got like this funky, skinny half bar. So that's not even anything either. So, yay, we're down to a 50-50 chance. So, the idea that I want you to think about when you're doing that is that from 50 to 60, how much of the data is there from 50 to 60? 50 to 60 should contain how much of the data? Yeah, from 50 to 60 should have half of the data. Okay, how about right here? From 0 to 10, how much of the data should you have? How much? 25% of the data. Okay, so I went through here and I kind of drew these. Okay, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this one has 13 items. And this is 6. Is half of it from 50 to 60? Pretty much. There's the median. How about this? Is this 25% of 13 items? Pretty much. Fourth. Okay? So I think B is looking good. Let's see if we can't debunk E. This is the problem. Is that one frequency a quarter of the values? Is this 25% of the values, items? This is not 25% of the items. That is why E is wrong. So therefore the answer is B. So this is, again, why E is wrong. Because from 0 to 10 is only one item. And that is from 0 to 10 is supposed to be 25% of the data. Okay. Number 13. Okay. The range of the sample can never be greater than the range of the population. That's true. And I want to give you a visual. Here we go. Pretend like this is the population of points. Okay, now I'm going to make a sample of points. Here comes the sample of points. They are in red. Here we go. Okay. Now, I could have even picked this top one. But is it possible that the sample is going to be larger than the population? No, because it comes from the population, so it can't be any bigger. It could be as big, but it cannot be any bigger. So, this is true. Number 2, while the range is affected by outliers. I want to ask you that. Is range affected by outliers? If you have data from 15 to 100, what happens if I change the top one to have an outlier to be actually 150. That's an outlier. Has it changed the range? Yeah. Outliers directly affect range. So while the okay, we're not talking about that, so we're not. While the range is affected by outliers, so it is. That's true. Is the IQR not affected by outliers? Is the IQR not affected by outliers? That is true, because if we start knocking off pieces of data to get to the middle 50%, they're knocking off the outliers. So the IQR is not affected. Okay, so that's true. That's good. Number 3, changing the order from ascending to descending changes the sign of the range. Range does not have a sign. Range is a distance. It doesn't have a direction like a negative sign. Range is always represented by a positive number. So you cannot change the sign if it doesn't have a sign. So what's our answer then? D, 1 and 2. Yes. Okay.
But it would only affect it if you took the outlier out of the equation. Or you added it to the equation.
Okay, so the question is, how is the range affected by outliers? Actually, this one is. Okay, so here we go. Listen up real quick. Here's the question. The question is, how is the range affected by outliers? Okay, you ready? This is 25 pieces of data. They go from here to here. Okay, well, guess what I did? I changed this piece into an outlier. So now, the next one in is here and here. So the range of this top one is this big. The range of the second one is this big.
Or if you change the far right one to an outlier,
Okay, if you change the far right one to an outlier, the range is not the same because it's farther out. By definition, high minus low is a different number. Okay.
Okay, say the far right maximum is like 140, and then you change.
Here we go. Okay. Next, 7 left. Okay, stay with me. I know this isn't our favorite thing to go through. It's pretty tedious. Here we go. Which of the following is true? If 2 students are working with the same set of data, they could come out with different looking histograms. We had that happen on like last 6 weeks. Some of you drew a histogram and your bins were 10 in length. And I drew the histogram and my histogram had 5s. Well, then you ended up having, different shaped. I remember when you guys did that, yours looked a little bit more symmetric than mine actually did. So I kind of actually liked the ones that went that way. Okay? Because I ended up having something like this. But anyway, the bin size can make them look different. So this is true. How about this? Displaying outliers is less problematic when using histograms than stem plots. For one, I can't necessarily even know if there's outliers with a histogram, but I could compute it with a stem plot, so this is not true. 2 is not true. Okay, number 3. Histograms are more widely used than stem plots and dot plots because histograms display the value of individual observations. Is that true? They do not. Therefore, the only one that is true is 1 only. Okay. On this number 15, I'm going to tell you that I literally went and put all of these pieces of data into my list 1 into my calculator. And I put all of these pieces of data into my list 2 of my calculator. And then I did the 1 variable stats of that list and the 1 variable stats of that list, because I just wanted to do that instead of having to tediously go through and possibly make mistakes on my computations. So the means ended up not being the same. The ranges were the same, the high minus the low. And then the variance, which is the standard deviation squared, were not the same. So therefore, 2 only. The range is the same. Did they really? Would it matter if I told you there was a hole punch right here and this was supposed to be a 7 and a 9? Probably. Okay. Anyway, so we'll go through and compute that. Okay. Working through them. Let's go. Next one. Here are 4 different items. Question. How can you tell which one has a smaller range? Which one has the smallest range? Is outlier counted in the range? Yes, it is. That's the point. Outlier is counted in the range. So these, this, and this, and this have much larger ranges because of the outliers. Therefore, C is the one with the smallest range. The outliers affect the range. Okay, next. 17. Hey, this is nice because it actually divides it up for you. So you can tell that there are 13 items. Therefore, item number 7 is the median. So that's going to be here. So is the median score 75? No. Even if you found that it was in this bar from 70 to 80, would you know that it's 75? No, because you do not know the individual values. Okay. How about this? If 90 and above is an A, is this most of the students? This is 5 pieces of data. Do most of them make an A? No. 5 out of 13 is not most. So neither one of these are true. Number 3. More students scored below 70. That's 4 students scored below 70 than scored above 90. That's 5. Is that true? No. So therefore, none of the above are true. That's E. Okay. Now, number 18 kind of messed with my head this morning when I did it because of this word. Which one of the following is possible? Okay, so let's talk about this. You ready? I want to draw you a picture. So I want to make it always concrete. So here we go. Here is a histogram of data. We have an upper outlier and we have a lower outlier. Then this problem talks about taking away the upper and the lower outlier. So then you have the data that looks like this. Okay, so this outlier is gone. This outlier is gone. I do not know if they're necessarily symmetric, but they are gone. Now, here's my first question before we get going into this. I want to know about the relationship of the standard deviations of these 2 sets of data. This standard deviation up here, the standard deviation here, will it be different than the standard deviation here when the outliers are gone? Will they be different? Yes, because the average distance away from the mean will be different, okay? Which one will be larger? The one that has far out values will be a bigger average distance away from the mean. So this one will be a larger standard deviation. So now let's go through these choices. Here we go. Both the mean and the standard deviation will remain unchanged. That is not going to happen. The standard deviation will definitely get smaller. So therefore, B is also not possible. The standard deviation definitely gets smaller. C is also not true because the standard deviation definitely gets smaller. How about E? Both the mean and the standard deviation increase. Is that true? No. The standard deviation gets smaller. Therefore, the only one that has even a possibility of being correct is D. If it is symmetric, then the 2 that were taken away were the exact same distance away from the mean and the median. They could be unchanged. So D is the only one that has the option, the ability to possibly be true. Number 19. Okay, this is a histogram, it says, but I actually have an issue with that because the years, how many years are accounted for this in 1999 to 2000? How many years is that? 2 years. So I'm just going to, like, for an example, draw the years the same amounts. So those could look like that. How many years are represented in this histogram, or in this bar? 3. So if they were even, they could be that way. And technically, the amount from here to here could be getting smaller. And then what about how many years are accounted for in this one? 4. So this also could be even smaller still. So therefore, do I know that each year since 1999 the total sales has increased? No, because I drew an example of that they could have decreased in value. How about the labeling has resulted in a misleading picture? Absolutely. 3, it is possible that the total sales per year decrease every year between 1997 and 2007, 1999 to 2007. I actually drew that that picture, what that picture would look like. It was largest here, then it was a third as much, and then so they actually did decrease. So this could happen. Therefore, the answer is 2 and 3. So 2 and 3 are the correct answers. So which answer choice down here is it? It is E. None of the above gives the correct set of answers. I know you don't like those, but that's the way it goes. Number 20. Do all 3 of these have the same range? Yes. Do they all have the same IQR? I don't think so. I think this one here is smallest IQR, so that's not true. How about all medians being between 8 and 12? Okay, there you go. They're between 8 and 12, so 1 and 3. And the last one. Okay, this last one, you know, people, is straight up from what I have been preaching to you since at the end of last week. So listen up. When a set of data has potential outliers, then you are bound to, you're restricted on what data is usable. So here we go. Which of the following are the preferred measures of center and variability? I always say spread. So what's the preferred measures of center and spread if you think that you may have outliers? Should you use mean and standard deviation? No. Both mean and standard deviation are affected by outliers. How about mean and variance? Oh, same thing. How about mean and range? Both are affected by outliers. How about median? And median's good. How about range? Range is affected by outliers. How about median and IQR? Yes. So your homework is the warm-up. We will talk about that the first 10 minutes of class tomorrow, and then you will quiz. Okay.